Namaskaram. Welcome to the course Basics of Electronics. In this video, I'll be talking on how to measure voltage and current in electronic industry. I will be covering 5 important topics in this particular video. First one is basics of voltage and current. Second one is the types of methods and the tools available for measuring the voltage and current. The third one is how to use multimeter for measuring the voltage and current. Fourth one is in-circuit voltage and current monitoring circuit with MCU for power monitoring. Last but not the least, fifth one is the safety precautions for measuring the voltage and current in electronic industry. So let's start. Basics of voltage and current in electronic industry. We already discussed about this particular topic in our previous videos, in fact couple of videos, which you can explore by looking into the playlist, and the link of I button is here. Now for the sake of quick understanding, I'll explain you what is voltage and current quickly. Voltage is the potential difference between any 2 points in electronic circuit. Say it is a 3.3 volt or 5 volt. And the current is the rate at which electrons are flowing from one point of the circuit to the another point of the circuit, which is always measured in terms of ampere, milliampere, microampere, or maybe a direct ampere. Basically, there are two categories in these two quantities. One is AC, another one is DC. With these two categories, we can categorize these 4 quantities. First one is AC voltage, second one is AC current, third one is DC voltage, fourth one is DC current. So these are the 4 majorly used terminologies in entire electronic industry throughout the design, development and manufacturing of complete hardwares. Let's talk about a couple of examples for your ease of understanding. Whatever the home appliances that we are using in our home, like refrigerator, fan or any kind of a home appliances, they work on AC voltage and of course AC current. The electronic gadgets that we are using right now, like smartwatch or maybe a Bluetooth headset or microphone or maybe a camcorder, all these devices working on DC voltage, be it a DC voltage or DC current, which is collectively said as DC power. Now let's talk about the different measuring tools and methods available for measuring the voltage and current in electronic industry. There are several tools and equipments available for measuring the AC voltage, DC voltage, AC current and DC current in industry based on the various application. The price and the quality of the tools are directly proportional or dependent on the accuracy and the precision at which they are working on. Digital multimeters are one of the most common tools used by every electrician and electronic engineer in their design lab. These digital multimeters can be used for measuring the AC voltage, AC current, DC voltage, DC current, resistance, capacitance, and some of them are also equipped with the temperature sensor. Along with these digital multimeters, there are some dedicated voltmeters and ammeters which can be used for measuring a specific voltage and current rating in industrial application. For example, 600 volt AC with 120 ampere of current rating, or as low as 1.8 volt of DC with 12 milliampere of current rating. Fundamentally, voltage divider circuit is used for measuring the voltage in electronics, whereas the shunt resistor is used for measuring the current flowing through the circuit. Voltage divider circuit is the very simple yet widely used electronic device for measuring the voltage in electronic industry. It employs a couple of resistors to reduce the voltage from higher level to lower level and connect the output of it to the ADC, which will convert that analog signal into a digital value, which can be processed by using a microcontroller and then evaluated with the standard calibration so that we can arrive at what is the voltage available across this particular divider circuit. Similarly, shunt resistor is also one kind of a resistor with a very low resistance value having a high power dissipation capacity, which can be used along with certain resistors to derive the voltage drop across this particular resistance based on the current flowing through it. And as usual, the output of this shunt resistor is given to a preamplifier and then ADC and then a microcontroller to process the data and understanding how much current is flowing through that particular sensor. These concepts are nothing but series and parallel connection of resistors in a specific way with a specific values. For more about this particular information, you can check our previous video about series and parallel connection of resistors and inductors and capacitor, link of I button here. Now it is time to know about the digital multimeters and how to use them for measuring the voltage and current in the electronic circuit. I hope you can see that there are two types of digital multimeter in front of me. One is very low quality, very simple and very cheap price of digital multimeter in front of me, which is Excel company, which is having a part number of DT9205A. And another one is a Fluke company multimeter with a 17B plus as a code. Now it is very simple and very straightforward for us to understand that this multimeter is having a very low accuracy and low precision compared to this particular multimeter, because this is very standard and very hard designed inside the multimeter with a very safety precautions and so many parameters to be considered while designing. However, there are some advantages and disadvantages which I am not going to talk and compare them. However, we are going to use both of these particular multimeters to measure the voltage and current inside this particular circuit. This is one of our product which is so called a Cobra head and tail, which is used for LED animation and all those things. So I am going to give a 12 volt DC from this particular DC power supply with a 500 milliampere of a current rating to this particular circuit, and I'm going to measure the voltage across the input, voltage across the output using both the multimeters and try to explain you what is the difference and how to measure them. Before going to that, I'll just take this particular multimeter and show it to you. We have an option of measuring the resistance here, and we have an option to test the diode and also transistor here. Also we have an option for DC voltage, AC voltage, AC current and DC current measurement. Along with this, we also can see that a farad, which is nothing but a capacitor measurement in this particular multimeter. So we have to remember that this particular red color probe has to be unplugged and plugged to the milliampere or ampere plug to measure the current. If you keep it here and try to measure, it is not possible. And if you keep the plug to current rating and try to measure the voltage, it is going to damage the multimeter. Similarly to this one, we can also see that the Fluke is also having a several option here. It is totally automated and it has a various features compared to this one. But you can see AC voltage, DC voltage and DC current, DC voltage again in the millivolt, which is a smaller voltage. And we can see ohm, which is resistance measurement. Along with that, we also can see that there is a buzzer indicator which is used for short circuit or continuity testing, and then diode tester is also there, capacitor measurement, capacitance measuring device inside there, and DC current, DC lower level current and very low level of DC current. Along with that, it also has a temperature measurement. External probe of a temperature sensor is given to you, which you can plug here and measure the temperature. Again, that is the high-end feature which is available with this high-end multimeter. Now here also we have to unplug this voltage probe, the positive probe, and plug it to the current where we are measuring the milliampere or ampere. Based on that, you have to plug it wherever it is. And whenever you are measuring the voltage again or any other than the current, then you have to unplug from here and plug it back here. So these are the two types of multimeters we have. Let me keep them here and let's start working on this particular circuit. Now I have connected this particular circuit with a two sample LEDs just to check whether it is working or not working, and I have connected the positive from the power supply to the positive pin of this particular input, and ground is connected to the ground. Now whenever I turn on this particular power supply, we can see a 12 volt drop across this particular input because we are giving a 12 volt from this particular power supply. Now when we have a 12 volt here, what could be the voltage at the output side, which we are going to measure by using a digital voltage section or digital voltage option in this particular multimeter. Along with that, we also try to measure the current flowing in this particular circuit by using the current setting in both the multimeter. Do remember, we are measuring the DC voltage and DC current. So do not plug these probes to the AC socket directly without having a proper knowledge, which can damage the multimeter as well as which can harm you or create fatal injuries. So now let's start this particular circuit. You can see that the LEDs are flashing, which means the circuit is working. Now in this particular multimeter, I will set it to a DC voltage. I'll set it to a 20 voltage range so that we can measure properly what is the voltage drop across the input. I'll connect the positive, which is a red color probe, to the positive pin, and negative, which is ground, to the ground. Now you can see 11.22 volt, or voltage is also decreasing because of variable voltage at the input load and output load. This is how the voltage is measured. Now if you want to measure the current, we have to switch from this positive to this side and then set the specific current rating in the multimeter and start measuring. Before that, let me show you how this multimeter will measure the fluke one. I'll just use the positive and negative probe and set it to a digital voltage. Here we don't have any range because here we have a range because it is very lower end, and we have to set manually what range of the voltage or a current we are measuring. Wherein in fluke multimeter we have already dynamic ranging, or you can say it is automatic. So VDC is looking over there, and I'm going to connect the positive pin here and negative pin here. It is showing the same voltage, pretty much same, 11.27 volt and 10.97 volt. It is varying between same range as this particular multimeter showed. In such high level voltage, it doesn't show any difference. If you are going for measuring the very low current or a low voltage, on that time the difference between these two will be visible to you. Now let's start how to measure the current or DC current in these two multimeters. First of all, what I'm going to do is I'm going to turn off the multimeter, both of them, and then I'm going to unplug the voltage point or maybe a positive probe of the multimeter and place it to the milliampere. Why? Because we know that this particular circuit is consuming less than 100 milliampere through this power supply indicator, as well as I know because we designed this hardware and we know what is the power consumption of this particular hardware. That's why I'm connecting it to a milliampere. If it is an ampere of a current rating, then we have to connect it to ampere, which can be used for AC voltage and for DC voltage. I think this doesn't have a DC voltage capacity, or it shows actually it has a DC voltage, but I have never tried any 20 ampere of a DC voltage, a DC current measurement using this multimeter. Similarly, in the fluke also, we have to change it from voltage section to a current section, which is a milliampere section. And then let's connect it in series. How to connect it? Of course, you should not connect it like this. If you connect it like this, it is going to damage the multimeter permanently. So for that, I just need to turn off this circuit and then remove the negative path of this particular circuit, negative probe from the power supply to this, or you can use the positive probe, whichever is suitable for you. So I'll use the positive probe. I'll just remove the positive probe, and we have a positive pin of this particular circuit here and positive pin from the power supply here. I'll connect the positive probe of the digital multimeter, I'm using a fluke multimeter right now, to the power supply directly. And then I will connect the positive pin of the input positive pin of the circuit to the negative probe of the digital multimeter. And of course, I have to set this particular digital multimeter to milliampere before turning on the power supply. So I'll just set it to milliampere first. Do remember, before turning on the power supply, you have to set it to milliampere, and then I'll just connect it like this. Holding this one like this is not good, but right now I do not have any resources properly to hold it properly. That's why I'm just holding it by my hand. I'm just going to turn on the circuit, and you can see that this circuit is working now, and the current showing over there is 45 milliampere to 59 or 60 milliampere, which is not near to this particular value, because the 40 milliampere to 58 milliampere it is going. Here it is showing a 45 milliampere. There will be a difference because this is not having a proper sensor inside, wherein this is very standard digital multimeter. That's why I trust this one, and I believe this circuit is consuming a 45.5 milliampere at the load level when the LEDs are turned off, and it is consuming 58 or 59, 60 milliampere of a current when the LEDs are turned on. Now with the same thing, we'll test it with this particular multimeter and come to the conclusion which is the right one. For that, I'll just turn off this power supply and I'll remove the fluke multimeter probes and I'll connect the other multimeter probe. I'll just use the same protocol, like positive pin or positive probe of the multimeter is connected to the positive pin of the power supply, and positive pin of the circuit is connected with the negative probe of the digital multimeter. Now what I'm going to do is I'm going to set this particular digital multimeter to 200 milliampere, because we know that it is 45-50 milliampere, so that's why 20 milliampere is not going to help us. So I'm going to set it to a 200 milliampere and then I'm going to turn on the power supply. When I turn it on, you can see that 46.3 milliampere and 61.7 milliampere is shown to us, which means I believe the fluke one is much better, because again this is a very low quality one, low precision, low accuracy, but still it is showing approximately near to this fluke one. But this power supply is having a completely different one, so I just ignore the power supply. I consider both of them. In smaller case of application, very simple application, I go with this digital multimeter, and in case of a very accurate measurement is necessary, on that time we can go with this particular multimeter. So you can see this is how the current is measured flowing through the circuit in electronic industry. Alright, now once you are done with doing a measurement of current or voltage, whatever it is, make sure that you unplug and plug the positive probe of the multimeter to the voltage point by default, because whenever next person is using this digital multimeter, if he or she do not see this particular positive probe of the digital multimeter and connect it to a voltage measurement, then it will damage the entire multimeter. Best practice is always keep it to the voltage point of the digital multimeter for the positive probe. And when you are done with the using, of course you have to turn off the digital multimeter. In this case, it is written already auto power off is there, but it takes a lot of time and it will consume the power inside. That's why what we do is we just turn it off when you are done with the using. Even with respect to fluke multimeter, we have to remove the current section or the probe from current section to plug it back to the voltage section by default when we are done with our working. So this is how to measure the voltage and current in electronic industry by using a digital multimeters. Now it is time to talk about the in-circuit voltage and current monitoring circuits with MCUs. It is very essential to monitor the voltage level and current flowing through the circuit in portable devices, because there is a need of power management with respect to the operation of the entire circuit. We can literally use voltage divider circuit and a shunt resistor to monitor how much voltage level left into the battery and also what is the amount of current flowing through the circuit and take a decision based on that. However, there are some dedicated power monitoring ICs available in the industry and they are called as fuel gauges. These fuel gauges are nothing but having a voltage divider circuit with a certain preamplifier inside, which helps us to monitor the voltage level and the current flowing through the circuit as precisely as possible. Now let us assume that we would like to monitor the 7.4 volt lithium-ion battery pack. For this, we would like to notify the user what is the percentage of charge left in the battery so that they can charge it whenever it discharges completely. So we are going to use a voltage divider circuit along with a microcontroller which has the ADC inside. Now it is a time for some basic calculation. We know that these battery pack, which is a typical voltage of a 7.4 volt made up of a 2 lithium-ion batteries, can have a voltage fluctuation between 6 volt to 8.4 volt. 6 volt being completely discharged, 8.4 volt is completely charged. But at the point of 8.4 volt, our microcontroller is having a maximum capacity of 3.3 volt sensing at ADC pin. So how do we do that? Of course, using a voltage divider circuit. We can divide the voltage of 8.4 volt to a 3.3 volt so that we can monitor that particular voltage with our microcontroller. It is as simple as whenever the battery voltage goes below as 6 volt, then the voltage of ADC pin goes less than 2 volt. And whenever the voltage of a battery becomes 8.4 volt, then the maximum voltage that comes to the ADC pin is 3.3 volt. To achieve this particular voltage divider activity, we need two resistors connected in series. First resistor is of 10 kilo ohm, second resistor is of 5.6 kilo ohm. And this is how the circuit looks like with the ADC pin connection. Now with the help of a basic programming with that particular microcontroller, we can literally derive what is the voltage of a battery by looking at the voltage at ADC pin. This is how the voltage sensors are designed in electronic industry. Along with couple of transistors and switching devices, these devices or these sensors can be made more optimistic, suitable for portable devices. Now let's talk about how to measure the current flowing through the circuit by using a shunt resistor. It is as simple as voltage divider circuit, only the difference is the current flowing through that particular resistor should be having a very low resistance with a high power dissipation. For example, if you want to measure a 2 ampere of a current flowing through the circuit, then your resistor should be capable of handling that much of current flowing through that particular network. If I consider the same microcontroller with the ADC pin which has a capacity of 3.3 volt at the maximum, and then if I use a Ohm's law formula for calculating the resistance based on the maximum current of 2 ampere and the voltage drop across that particular resistor should be 3.3 volt or less than that, then the resistance value comes down to 1.65 ohms. Very weird, right? But yes, that is how it is. 1.65 ohms of resistance with the power rating of maybe a 10 watt or 20 watt can be used for this particular application. In these both applications or both circuit, voltage at the ADC pin oscillates between 0.5 volt to a 3.3 volt, be it a voltage sensor or a current sensor. Based on the variation of this particular voltage, we can literally detect what is the voltage level at the battery and also how much current flowing through that particular resistor. So it's as simple as that, but it is a very crude method with a lot of noises in the entire circuit, which has to be eliminated by several filters and so many electronic design engineering parameters, which we are not going to touch in this particular video, but I hope you got to know how to measure the voltage and current in electronic industry. Alright, now it is a time for discussing on the safety instructions or safety precautions in electronic industry. It is very dangerous and harmful if you mishandle any measuring equipments. In simple case scenario, it will damage the microcontroller or maybe a circuit. In a worst case scenario, it can create a fire in the entire system if it is not handled properly. If you are not using any safety fuses with safety precautions, then it can damage so many things around the entire circuit. In worst case, it can even damage a human who is using that particular hardware. There are various methods and protocols to ensure the safety of measuring equipments. Let me share a few of them with you. First one is never ever connect voltage sensor as a current sensor and current sensor as a voltage sensor, because of their circuit connection and circuit connectivity, they can create a short circuit in the entire circuit and it will damage like anything. So that's why do not connect voltage sensor as a current sensor or current sensor as a voltage sensor. Second one is do not touch the metal part of the any electrical probes when you are measuring the AC quantities. For example, AC voltage or AC current, because they can create a fatal injuries if you are not handling them properly. That's why do not touch any metal part of the measuring probes. Third one is do not select the wrong option when you are measuring certain electrical quantities. For example, if you are using a DMM and measuring a AC voltage, do not set an option in the DMM to a DC voltage. Or for that matter, if you are measuring the voltage, do not set the DMM to the current setting. Or when you are measuring the current, do not set the DMM to the voltage setting, which can damage the entire multimeter, or in a worst case scenario, it will even damage the circuit that which you are measuring as well. Fourth one, do remember you have to unplug and plug the positive probe of the digital multimeter when you are measuring the current to voltage or voltage to current. For example, if you are having a DMM with 10 ampere of a current rating, when you are measuring a 10 ampere of a current through that particular circuit, then you have to plug from voltage selection to plug it to a current selection. And similarly, when you are measuring a voltage, then you have to unplug it and plug it back to the voltage selection. Fifth one is do not measure the current flow in the circuit when the circuit is on. unless you are very much sure and very much aware what you are doing and how you are doing is correct method. If you are not having any experience, without having proper idea what will happen with the circuit or with you, do not try to measure the current flowing through the circuit when circuit is on. These are the 5 precautions or instructions to be taken care while you are handling a DMM or any other equipments to measuring the voltage and current in electronic industry. I hope you enjoyed the complete process or the detailed walkthrough about how to measure voltage and current in electronic industry. See you again in the next video. Until then, happy learning. Namaskaram.